Welcome to my video. My name is Harshal and this is Operating System Lab. Experiment number 6, implementation of deadlock avoidance algorithm, Banker's algorithm. So in this experiment we will see what is the Banker's algorithm, and that we will implement in Python and see the program and what is the Banker's algorithm output. So let's begin this video. So in the descriptions it is the Banker's algorithm. In a multi-programming environment, several processes may complete for a finite number of resources. Means in a multitasking environment, a multi-programming environment, there are many, there are a finite number of resources, and the process requests resource if the resource are not available at that time. Means the process request for the resource but that are not available at that time, so that time is known as a waiting state, and the waiting process is never again able to change, so that will be for the waiting process. And means it is like a deadlock. Means A, B, C are the three processes. A is requesting B, B is requesting C, and C is requesting A. Means for A, the condition is A is asking for the need of B, but the condition is A is having the first thing, but A has not completed its work, but it is requesting for B to give the requirement, but B requirement is having with C, but C is telling that C is not having the requirement that is for A. Means that condition is known as the deadlock. For that we are using the Banker's algorithm. So in what is a Banker algorithm? Like, means there are the process, and there is one matrix, that is n into m, that is a matrix, and the maximum of instance of each resource each process can request. Means the maximum of instant resource of each resource can reach each process can request. And if the maximum a I j is equal to k, means this is the maximum, then process pi may request for the instance. Means this maximum process will request for the k instance, and then the all the process that are there, everyone is allocated as their job, and when the allocation is there, the allocation will be what is the allocation, that is n into a matrix, and it will be allocated to each, and then each will be having as their need that they will ask another, and the available resource will be there, and need my allocation minus max, that is the for the need, and then it will take the allocation, and from that we have to see whether we will find the safe state, whether it is having the safe state or not. And next it will get the output, that is the available resources are there, the processes are there, and from that we will see the safe sequence, and we will get the processes max allocation and need, and we will get the algorithm, that is we will see in the program. So this is the program. For the output we will get in the Banker's algorithm. So here there are the n number of process, so we will enter n number of process, n number of resource, we will enter n number of resource. Next allocation matrix, that will be empty, maximum matrix, and available resource. So here it is allocated as null. Then for I in range, it will ask the process to enter the user to enter details such as processes, and then it will be allocated for the allocation matrix. Means this process will be add, and then it will ask for the process one enter allocation and matrix, and then it when we enter this, the available resource are there, we will enter that, and next we will add the resource, that is requesting for the resource, and then we will this will check the requested resources, and then need is equal to this need is equal to max minus allocation, means the max minus allocation. We will get the allocation, and my allocation means this is the process. This is the five process are there, three resources are there, a b c. A is having 10, b is having 5, c is having 7. These are the processes that are allocated for the process 0 1 2, and this is the maximum matrix, and here is the available. So here the first thing is these are available. From this two we will minus, means 7 0 minus 7 7 1 minus 5 4 0 minus 3 3, like that we will minus everything, and we will get the need matrix, and this is the available. If this satisfies, then it will show it is in the safe state, or it is not, and it will show the safe state sequence. Means example, p4 will be p4 will come first, then p1 p2 p0 p3, like that the safe sequence will come, and then it will print the safe sequence, and it will show the allocation. So here this thing it will do. For here it will ask, firstly we took all the data from the user. Next, the main work it is there, that is the f. So this is f. It is it is multiplied by number of process, and this will calculate is the need, that is maximum resources minus maximum minus allocation. So here it will calculate this for I in range. For I in range, that is for the process. For j in range, that is for the, sorry, the first I in range, that is for a process. For j in range, that is for resource. So need minus max matrix and allocation matrix, and when this it is minus, then we will get the total, that is of the need, and from that we will calculate the available resource. For here it will calculate if the flag is equal to a flag of I is equal to 0, then flag is equal to 0, and this if need is greater than available, then the flag is 1, then it will break. So here it will calculate this, and it will print if flag is equal to 0, means the flag is 0, then it will add the matrix, and it will show how many p1 is visited, p2 is visited, like that, and then it will go to the safe sequence, and it will show the safe sequence state, and like that p0 p1 p2, like that it will show the safe sequence, and it will show whether it is a deadlock or not, and this will show the active allocation matrix I need in the table. So when we run this, we will get, for that it is 5 resource, and process are 5, resources are 3. So here when we see, we will enter this. So here allocation 0 1 0, matrix 753 200 for p1, for max 322 302 302 902, for p3 211 triple two max. Detail for p4, that is 002 and 433. So we have to enter here. Now what are the available resources? So we will get the output 332. So if I entered here, for example 2, process ID 2, requesting resource 10, sorry, 102. Here it will show that the P1 is visited 122, P3 is visited, P4 is visited 431, P0 is visited 743, and P2 is visited 600. So it is in a safe sequence, and the sequence is P1, P3, P4, P0, and P2. So this is the sequence, and this is the allocation table, max and the need. So the allocation is, so allocation minus max. So this 0 minus 7, 7, 1 minus 5, that is 4. So from minusing this we are getting the need, and this is the available resource, and this is the requested by P2. So the requested resource are this. From this we are getting the output of the banker's algorithm. So this was the experiment number 6 of operating system implementation of deadlock avoidance algorithm, banker's algorithm. Thanks for watching my video.